Okay, well, welcome back. This is a follow-up to the CSIAC presentation given by Taz Daughtrey on December 5th. My name is Tom McGibbon. I'm the director of the Cybersecurity and Information Systems IAC, and we have Taz here again today, and I thought, Taz, it would be good if you could summarize a little bit about what you told everybody about the other day.
Sure. Thanks very much, Tom. The topic was software security growth modeling, and the idea was to see if we could explore a little bit building on the idea of a more well-established technique, which is software reliability growth modeling. One of the things that we're always concerned about with any kind of software and with any kind of sensitivity or failure modes or any other demands we have is, when is the software good enough? And software reliability growth modeling has been a technique that's been used for quite a while. There are a number of mathematical models. There are several tools, such as the Smurfs tool, that give you a front end in which you can enter data from the testing phase of your software development that will give you some projection of how reliable the software is going to be. And so my thought was that if we could look at the limitations as well as the successes of that kind of modeling, we might be able to apply that to the idea of how we might understand the growth of security. Now, what happens when you're testing basically is you're doing what from a quality point of view would be called sampling, and you're sampling with repair and replacement. That is, you run the software, you encounter a failure, the failure indicates there's a defect, you go and fix the defect, and go back and run the software again. So in that process of sampling, there's underlying quality models, statistical models that allow us to say, well, how much better are we getting as we find and remove those defects? For security vulnerabilities are essentially a subset of defects in software. The vulnerabilities are the defects in the software that can be exploited so that software requirements are not met. And so the same idea in terms of doing testing is that when you encounter a defect, and particularly for security, a security type of defect that would be regarded as a vulnerability that could be exploited, you again want to remove the defect and repair the system and rerun your test. And so, as with reliability growth modeling, if we in fact could do some security growth modeling, we might have a chance of beginning to at least start to quantify how much better is the software getting, how much more secure is the software, and then ultimately, is the software good enough? Is it secure enough? And so that was basically the idea. Went through a number of details about certainly some assumptions and limitations in reliability growth modeling. And in addition to those, even more problematic are a number of assumptions that have to be made, or some simplifications that have to be made in security modeling. So it's as much a plea or a call for people to engage in some additional research and some additional discussions, but to the extent that security issues are a subset of reliability issues, and that security vulnerabilities are a subset of defects in the more general sort, then it might be that as a special case of what we know with reliability growth modeling, we might be able to apply those ideas to some sort of modeling of the growth of security as we're doing testing and analysis, removing vulnerabilities, and then rerunning the system.